In this video, we will go over problems related to areas and circumference. Let's begin with a few area formulas, and I do want to start at the beginning and let everybody know that on upcoming exams, all the formulas related to area and circumference will be provided within the exam. So all you have to know as a student is how to work with them. We begin with the area of a rectangle and the area of a square. Now, area is the amount of space covered within a particular polygon. We know that rectangles have 4 different sides. 2 sides are length, 2 sides are width, and they're equal. The area for a rectangle is length times width. Now, a square is just a special form of a rectangle. It's a rectangle with all equal side lengths. So if this is side length S, this is side length S, as is the remaining 2 side lengths. Area for a square is length times width, but that's S times S, or side length squared. Now, area for a triangle, if we have a triangle, we have 2 parts to the area formula for a triangle. The area is the 1/2 times the base of the triangle times the height of the triangle. So if my triangle is oriented in the way that you see on the screen, the flat portion will be my base, and then from the middle of that up to the peak of the triangle, that would be the height. Now in this right triangle that you can see on the right side of the screen, here we would call this the base and we would call this the height. So area is 1/2 base times height. So keeping that in mind, let's find the area of these figures. At first glance, we realize it's not just one polygon that makes up this particular shape. In fact, I've got 2 rectangles that are somewhat glued together. I could imagine that this rectangle continues out here. So we've got the rectangle that's oriented horizontally, and then the rectangle that's oriented vertically. So if I could find the area of those 2 rectangles separately, I could add the result together, and that would be the area of the entire figure. In order to find the area of the horizontal rectangle, all I need is the length and the width, because we know area is length times width. And for this one, we actually have the width is 4 and the length is 20. So I could find the area here, and it would be length times width, 4 times 20 is 80 feet squared. Now to complete this problem, we need to find the area of the vertically oriented rectangle. However, before we can do that, we need to know what is the length of the rectangle and what is the width of the rectangle. Now we have all the information we need, we just need to put it together in the right way. We know that the overall length that I'm highlighting here in tan is 18 feet. Notice that's a little more than we wanted. We have the portion that we want plus this extra spot here. However, by symmetry, we know this extra amount that we don't want is exactly 4 feet. So 4 feet plus the part that we actually want is 18 feet in all. That tells us the missing piece must be 14 feet. So this unknown side length here is 14 feet. Next, we need to find the width of this vertically oriented triangle. In a similar way, we know that overall this is 20. And this, by symmetry, would be equal to the opposite side of this rectangle, which is here. We see that's the portion that we actually want, plus the 16 feet. So we have the idea that our unknown side length, if we add that to 16, we'll get 20. This tells us the unknown side length must be 4. Now our goal in finding these side lengths is so that we could find the area. We know the area is the length times the width. So area here is 4 times 14. That is equal to 56 feet squared. So the area of the entire figure is the area of the top rectangle plus the area of the bottom rectangle. Adding that together, and we get a total area of 136 feet squared. So in this next problem, it says a sailboat has a triangular sail with a base of 12 feet and a height of 5 feet. Find the area of the sail. Just for practice, let's draw this so we know it looks like a triangle. The base of the triangle is 12, the height is 5. So our sail looks something like this. We know the area formula for the area of a triangle is 1/2 base times height. So that'll be 1/2 times the base of 12 times the height of 5. And that'll get us exactly 30 feet squared. So we've worked with the area formulas for squares, rectangles, and triangles. Now let's look at formulas related to circles. So whenever we're looking at a circle, we have the area enclosed by the circle, which is the area, and the distance around the circle, which is the circumference. So let's begin with the definition of circumference. The distance all the way around the outside of the circle is called the circumference, and the circumference of the circle can be based on both its diameter and its radius. There's two different formulas, both which give you the circumference. Let's first visualize what is the diameter of a circle and what is the radius. Whenever we talk about the diameter of a circle, we mean the distance all the way across. So the diameter is the distance from one point on the circle directly across the circle. The radius is half that distance. So the radius is from the center of the circle out to any of the edge of the circle, or the outside of the circle, I should say, not edge. So from the center of the circle to the outside of the circle is how we measure the radius, r. Now, based on whether you know the diameter of a circle or the radius, which is half the diameter, the formula for circumference is pi times diameter, and the formula when given the radius, circumference is 2 pi r. And the reason this works is 2 times the radius is exactly the diameter. Because the radius is halfway across the circle, the diameter is the complete way across the circle. Now, if you haven't seen this symbol that I wrote out, pi, earlier, you can look on most of your calculators should have a button here for pi. For our class, so that everybody's answers are consistent though, pi is a transcendental number, so it's a number that continues its decimal places out infinitely without ever repeating decimals or fixing on a certain pattern. However, the first few decimal representation of pi is that pi can be rounded to 3.14. So for our class, in all calculations, use the value of pi 3.14. Although that is an approximation, it'll just make all of us have similar calculations. And finally, before we move on, let's just visualize the circumference. The circumference is the distance around the circle. So if we could maybe, for any circle, get a piece of string, outline all the way around the circle, and then when we straighten that out and measure it, that would be the circumference. Our next formula is for the area of a circle. So how much area does a circle enclose? And that will be based on the radius of the circle. So given the radius, that is from the center outwards, we can find the area of the circle using the formula that area is pi r squared. And we know for our class, instead of pi, as in the transcendental number, we're going to use the rounded version of pi. So our formula will become 3.14 times the radius squared. Let's apply these formulas for circumference and area in the next example. So in this next example, we are asked to find the circumference and the area of each of the circles. So our first circle, we're told, has a diameter of 12.6 centimeters. Now, on this circle that you see described here, think about where you would visualize the diameter. What does the diameter measure? The diameter measures the distance directly across the circle. So I can write in my diameter from this point to the point directly opposite this from the circle. That is my diameter, and for this circle it measures 12.6 centimeters. Now I know that I can use the diameter to find the circumference. We have the formula circumference is pi times diameter. However, whenever we look back at our area equation, the only area equation we have is pi r squared for a circle. So even though they gave me the diameter, I need to turn that into a radius measure so that I can find the area. So remember, the circumference formula has two options. You can do it based on the diameter or based on the radius, but the area for a circle is based off the radius. So let's find the radius for this problem. We know the radius is exactly half the diameter. So for us, that will be 1/2 times 12.6. That will get us a radius of exactly 6.3. So now that we have all the necessary values, we can plug these into our formula. So we know that we're using, instead of pi, so that we're all in the same page, we're going to do 3.14, the rounded version of pi, times the diameter of 12.6. And when we multiply 3.14 times 12.6, we get 39.564 as the circumference. Now, circumference is a distance, so this will be in the linear units, so just centimeters. Next, let's find the area. We know the area follows the formula pi r squared. Now again, we use the rounded version of pi, 3.14. We already found our radius to be 6.3, and then we square that. So let's type that in the calculator. So I'm first going to square 6.3 in the calculator. Then we'll multiply that by 3.14. And we find 124.6266 on our upcoming online quizzes and exams. Be sure when you do these problems, if it goes on for many decimal place, within the quizzes and exams, there will be a certain rounding that is mentioned. So just pay attention. Does it say round to 1 decimal, 2 decimals? Here, let's just leave all 4. And we find the answer that the area enclosed by this circle is 124.6266 centimeters squared. So since area is a measurement of flat space, we know that that will be centimeters squared. Now the next problem is very similar. We just have a circle with a different radius measure, so the radius is said to be 1.7, and you're asked to find the circumference and area. As this is related to the last example that we did right above this, I would encourage you to take some time and pause the video and attempt this on your own, and then when you're ready, unpause to check your work. So first, I'm just going to quickly sketch what we know about this circle to give us something to focus on. We know the radius, which is the measurement from the center outwards, is 1.7 meters, so let's draw that. So here's an approximation of my center, and then we're going to measure out towards the boundary of the circle. That's the radius, and it is 1.7 meters. Let's write down our formulas. We know circumference, when we're given the radius, we should use the 2 pi r version of circumference. It is equivalent to pi times diameter because 2 times the radius is the diameter. We also have our area formula, pi r squared. And in this case, unlike our last example, we don't have to solve to find the radius. We are already given that at the beginning. So we can plug into the formulas 2, use the rounded version of pi, 3.14, times 1.7. Typing this into the calculator, we get the circumference is 10.676 meters. Next, we calculate the area of this circle. We use the rounded version of pi, 3.14, times our radius was given to us to be 1.70, square that. Type this into the calculator. So we take 1.70, square that, multiply it by 3.14, and we get the area of 9.0746. The base unit is in meters, but we know area is a squared unit, so this will be meters squared. So in our next example, we're asked which of the following is a better buy: a large pizza with an 18-inch diameter for $20, or a medium pizza with a 14-inch diameter for $14. In terms of determining whether it's a better buy, we can see that the large pizza costs more than the smaller pizza, but it costs more for a larger item. So whenever we're comparing prices of different sized items, we need to think about the unit price. And this can apply in all sorts of shopping situations where you're considering different prices for different sized items. Unit price will always be the cost divided by whatever you're scaling it against. So for instance, if I was comparing a 5-ounce can versus a 10-ounce can, I would do cost divided by ounces. Here, when I'm measuring what's a better cost effectiveness for pizza, the amount of pizza that we'll eat is based on its area. So for this particular problem, the unit price will be the cost per pizza divided by its area, because the amount of space covered in the pizza is what we'll be consuming, so the cost divided by that will give you the unit price. And in this context, the better buy will be whichever gives a cheaper unit price. So in order to determine this, let's first draw our two pizzas here. So you can see I've sketched out a smaller pizza and a larger pizza. So the medium one, 14-inch diameter. Diameter is the distance all the way across the circle. So the diameter for the medium pizza is exactly 14 inches. Now, whenever we think of area for a circle, we think the area formula is pi r squared. So what we need is not the diameter, but the radius. So we're given the diameter, but we can find the radius because the diameter is related to the radius in that half of the diameter is the radius. So the radius is equal to 1/2 the diameter. So for our problem, we've got 1/2 times the diameter of 14 gives me a radius of 7. So I've drawn in half the distance across from the center out is 7 inches. Similarly, find the diameter labeled on the diagram and the radius for the larger pizza. We know the larger pizza is an 18-inch diameter. Now halfway across that is exactly 9 inches. So the radius for the larger pizza is 9 inches. Now let's calculate the areas for both the medium and the large size pizza. We have the radius for both. The medium size pizza is 7 inch in radius. The large pizza is 9 inches in radius. So the area is pi r squared. So we use the rounded version of pi, 3.14, times the radius squared, versus the large pizza is the rounded version of pi, 3.14, times the radius of 9 squared. Type both these into our calculator and we will get 153.86 inches squared for the medium pizza, and then 254.34 inches squared for the large pizza. Now that we have the areas for both pizzas, we're able to calculate the unit price. So the unit price, again, is always cost divided by what you're measuring things against. For this problem, in order to compare the large and the medium pizzas, I need to compare their areas. I also could compare their weights, but I have no way of calculating the weights. Given the diameter, I could find the radius, and with the radius, I could find the area. So the unit price for the medium-sized pizza will be the cost, which if we read was $14, divided by the area. Typing that into the calculator. And we get a unit price of let's keep maybe the first 5 decimal places, 0.9099. We look past the 9, it's a 1, so it stays there. And that's dollars per inch squared of pizza. So the medium is about 9 cents per inch squared. Now let's find the unit price of the large. The large pizza had a cost of $20 compared to an area of 254.34 inches squared. So its unit cost will be 20 divided by the area. And then we'll just type this into the calculator. And we get 0.78634 continuing. So let's keep it to the first 5 decimal places. That will be 0.7863. We look past the 3, it's a 4. That means you keep it the same. Dollars per square inch. And as we're considering which is the better buy, we're looking for which one gives us the least cost per unit. So that would be the large pizza. It is 7 cents per inch squared about, compared to the 9 cents per square inch of the medium. So we'll just write down, since this is the lower unit cost, the large pizza is the better buy. Now our next example has a wall pennant is in the shape of an isosceles triangle. Remember back to a previous lesson, the isosceles triangle is a triangle where two of the side lengths are equal length. So let's draw that on our page. So here's our isosceles triangle. The way to indicate that two sides are equal is again just to do a dash through them. That means this side length is equal in length to this side length. We know that each of the two sides measures 18 inches more than the third side. We know the overall distance around the triangle, the perimeter, is 54 inches. And we're asked, what are the lengths of the sides of the pennant? My first idea is, since we don't know particularly the length of the smaller side length, and it's referenced in terms of giving us a relation to the other two side lengths, let's name that third side. The third side will be the x. So this is my x in the picture. And it said that the two side lengths that are equal, the other two side lengths in the triangle, they're 18 inches more than the third side x. So what do you think you would write here? This unknown side length in words is 18 inches more than the third side length, which we're writing as x. So how can we write that as a mathematical equation? Well, the idea of 18 more, that's the idea of like adding 18. Adding to what? The third side length. So here I'm going to have the third side length, and if I add 18, that's the distance of this one. And since it's an isosceles triangle, the other side length must also share the same value. Now we're almost to the point where we can connect all this. If you measured all the side lengths together, x plus 18 plus x plus 18, that is the distance all the way around the triangle, which is equivalent to the perimeter. But we know the perimeter is specifically, in this example, 54 inches from the problem statement. Now the question that we're trying to solve is, what are the lengths of the sides of the pennant? If I knew what x was, do you see that I could find the other two side lengths because they would just be that value plus 18? So now I've been able to write the equation that will allow me to solve for x. I see I've got x, that's 3 x's. 18 plus 18 is 36. And we combine that, they combine to be 36, and that's equal to 54. Now we can solve to get x by itself. We'll subtract 36 from both sides since it's currently being added, do the opposite. And we get that 3x equals 18. Now here we might be able to think about it. 3 times what gives you 18? That's 6. Or if you need to, you can divide both sides by 3 since it's currently being multiplied. And we see x is 6. Let's label this in our triangle. If x is 6, can you find the other two side lengths? Yes, because the other two side lengths are 18 more than x. So this would be 6 plus 18, which gives us 24, and this side is also 24. So the side lengths of the triangle is 6, 24, and 24. Now for the next two examples, there's two ways that we can go about the problem. I'm going to illustrate both methods for the first one, and then the next example is very related to this in ideas of how you'd go about solving it. Based on which method you preferred from this example, you'll know how to start the next example. So let's read through. It says a carpet cleaner uses 8 ounces of shampoo to clean an area 31 feet by 31 feet. So for a 31 foot by 31 foot area, we need 8 ounces. So these are linked ideas. 8 ounces of shampoo covers a 31 by 31 foot area. How much shampoo would be needed to do a larger area, 93 feet by 93 feet? So we're saying how many ounces would cover 93 by 93? Now the first approach that we might do is proportions. In using proportions, you relate what you know about one piece of information, that is there's 8 ounces to clean an area 31 by 31 foot, and then compare that to say if I did a different size area, how many ounces would I need? Now before I go about the proportions problem, the first thing I need to do is 31 by 31 is not an area itself. It said the area of a space that's 31 foot by 31 foot, so this is, since they're equal side lengths, a square 31 by 31. And we know the area of a square is side length times side length, or 31 squared. That would be 961 feet squared. So in setting up the proportion, we compare like things across like things. So I'm going to do ounces over area. So for the smaller portion, it took 8 ounces to cover a 961 foot squared area. And for our larger portion that we don't understand, it takes an unknown amount of ounces, maybe we'll call that X instead of question mark, to cover an area. Well, here I need to calculate this area. Again, this is a square, 93 by 93. So its area is 93 times 93. And that will be 8,649. And now I can solve for X. And if you haven't seen proportions before, whenever you set up proportions, notice I have the related information on the same side. So for the 8 ounces and the area that's 31 by 31, that's on the left side. For the bigger area, that's on the right side. And then you have same things on same sides, but then you also have ounces on the top, areas on the bottom. So you're combining like things, you're comparing like things both opposite each other and in the same location. So I've set up my proportion correctly, and I can solve by X by the phrase cross multiply. By cross multiply, I mean take the bottom of the right side times the top of the left, and then in the opposite direction, take the bottom of the left times the top of the right. So 8 times 8,649 is equal to 961 times X. Now let's simplify what the left side is. So the left side is 69,192. The right side is our 961 times X. We can get X by itself if we do the opposite of what's currently going on. Currently it's being multiplied by 961. So let's divide both sides by 961. That will give us that X, the amount in ounces, should be 72 ounces. So this method was solving the problem using proportions. Now let me introduce a second way you could solve this problem. And it's up to you, whichever way makes most sense to you, go with it. So in another way to attempt the problem, I noticed that the two areas are somewhat related. How is 31 related to 93? 31 plus 31 plus 31 is 93. So to cover an area 31 foot by 31 foot, it took 8 ounces. Now if we want to expand that out to a 93 foot by 93 foot, we know that 31 plus 31 plus 31 feet is 93. So currently, this is a 93 by 31 rectangle. Now I want a 93 by 93, so what I need to do is follow this out and have another row of 31 by 31 by 31, followed by another row of 31 by 31 by 31. This is now a 93 by 62, so one more row and we'll get to 93 by 93. So here we have a 93 feet by 93 feet square, and we can quickly count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 bottles of 8 ounces each used. So we'd say 9 times 8, and we get the 72 ounces that we got using the proportion method. So our next example is related to this idea. And as in this example, you could solve it either by using proportions, or if you prefer, this method of seeing how could I expand out the piece that I understand, the 31 by 31 foot square using 8 ounces, how could I extrapolate that out to fit the 93 by 93 foot? So our next example is a ceiling measures 9 foot by 15 foot, could be painted for $60 in all. Now whenever we think about the ceiling 9 foot by 15 foot, we've got a rectangle, and to paint it cost $60. How much would it cost to paint a ceiling that's larger, 18 feet by 30 feet? Now this problem is similar to the one that we just completed. I would encourage you to pause the video now and attempt this on your own. And then when you're ready, unpause and check your work. So I'll go over this problem using both methods as we saw in the last example. Let's first realize that 9 foot and 15 foot are very related to the later values of 18 foot and 30 foot. For instance, 9 plus 9 is 18, 15 plus 15 is 30, so using the method that we just completed in the last example, I could stack two of these rectangles side by side and get a 30 foot by 9 foot, extend that out one more row, and I'll get the 18 foot by 30 foot. So we now have our 18 foot by 30 foot ceiling broken down into 9 by 15 foot sections, and there's 4 of those sections, so each of the 4 sections would have cost $60. So our overall cost is 4 times 60, or $240. So that's one method. If we prefer the proportion method, I need to compare area to cost. Now I need to quickly find the area here. The area is 9 times 15, that will be 135. And we need to compare that to this area, which is 18 times 30. Type that in the calculator, and that's 540. So then I need to compare same things to same things. So let's say we do area at the top, divide that by cost. Now for the area of 135, I had the cost of 60. And for the area of 540, I have the unknown cost of so many dollars. So then we will compare an area of 135 cost me $60 compared to an area of 540 using the same unit price cost me X dollars. Now I can solve if I remember the phrase cross multiply. We know the top of the left times the bottom of the right, bottom of the left times the top of the right, and we get 540 times 60, which is 32,400. To get X by itself, it's currently being multiplied by 135, so I divide both sides by 135. And we get 240 as we found before. So by either method, we'll get to our final answer. It just depends on you which method you prefer, and then keep that in mind if you see similar problems in our upcoming quizzes or exams. So just as a quick recap, remember we had a few different formulas for area and circumference of different figures. In the upcoming exams, the area formulas will be given. You just need to know how to work with them. So as always, if you have any questions, don't hesitate to reach out through our Canvas email, our campus email. I'll be very happy to respond and help you, and I hope you have a great day.